This is the screencast for Section 3.3, Example 9. Calculus is the study of how things change. So anything that is changing needs calculus in order to calculate it. So in the past, any word problems that you have worked with have studied a moment in time or something that never changes. We, however, are now going to study something that is growing, something that is maybe lessening, something that's doing a whole bunch of movement. We're going to study it at an instant, what is happening at that instant. So example 9, an orange farmer currently has 200 trees, yielding an average of 15 bushels of oranges per tree. So 200 trees is an amount of trees. However, it is changing. Right now she has 200 trees, but next year she's going to have more, and the year after that she's going to have more. And they yield or produce an average of 15 bushels of oranges per tree. So these trees are producing 15 bushels of oranges per tree. She is expanding her farm at the rate of 15 trees per year. So like I said, this year she's got 200, next year she's going to have 215, next year she's going to have 230, etc. While improved husbandry is improving her average annual yield by 1.2 bushels per tree. So just first of all, to clarify, improved husbandry doesn't mean she found like a better husband to do her work for her. That's not what that means. Husbandry is tree farming. And so her average annual yield is improving by 1.2 bushels per tree. So right now, she's getting 15 bushels per tree. Next year, she'll be getting 16.2 bushels per tree. And then the following year after that, she would be getting 17.4 bushels per tree, etc. So things are changing in this farm. It is not staying the same. The question is, what is the current or instantaneous rate of increase of her total annual production of oranges? So right now, what is she predicting for her rate of change for total annual production of oranges? So let's get some variables down here first. Let R equal the total number of bushels of oranges. I don't like using O because O is like the number 0, and B is going to be my bushels per tree. T is then going to be her total number of trees. So when we take the derivative of each of these, the derivative is going to represent their rate of change. So R prime is going to be the change in oranges, total oranges. T prime is going to be the change in number of trees. And B prime is the change in number of bushels per tree. Now this may sound really confusing, but here's some good news. Every calculus word problem starts out with a basic Algebra 1, Geometry, or Algebra 2 setup. That's it. Like really, really basic. So, for example here, look at R, T, and B. So no derivatives involved. Her total number of bushels of oranges, her total, is going to equal the number of trees she has times the bushels per tree. That's it. The total number of bushels is going to be the number of trees times the number of bushels per tree. So at this point, you were probably thinking, well, it's 200 trees and 15 bushels per tree, so I just take 200 times 15. Well, these are changing. That's where calculus comes into play. So now I'm going to take the derivative. The derivative of R is R prime. And you can see here, trees are changing as a function of time, and the bushels per tree are changing as a function of time. So I'm going to have to use the product rule here. I'm going to go T times B prime plus B times T prime. The product rule. Now I can plug in some numbers. R prime, which again we are solving for, means the change in total bushels of oranges, the change in bushels of oranges, is going to be the number of trees. So she's got 200 trees times B prime. B prime is the change in bushels per tree. So that's 1.2. She's improving by 1.2 bushels per tree per year. Plus B, the number of bushels per tree, we said was 15. And then T prime, her trees are changing by 15 trees per year. So to recap, the question is asking us, what is the current instantaneous rate of increase of her total annual production of oranges? So we are not looking for the total number of oranges. We're looking for the increase or the rate of change. So R is her total number of oranges, which equals the trees times the bushels per tree. If we take the derivative of that, we get how fast the bushels of oranges are changing for her total production. And we use the product rule. So we get, this is 465 bushels per year. So in other words, right now she's got 200 trees yielding 15 bushels of oranges. Next year, she's going to have 215 trees at 16.2 bushels per tree. That's going to increase her yield by 465 bushels per year. So let's take a look at the Now Try problem number 51. It is the exact same setup, we're just using different numbers. So of course I encourage you to pause this and try it on your own. So now we're orchard farming, we're not doing oranges anymore, we're doing apples. An apple farmer currently has 156 trees, yielding an average of 12 bushels of apples per tree. He is expanding his farm at a rate of 13 trees per year, while improved husbandry is improving his average annual yield by 1.5 bushels per tree. What is the current instantaneous rate of increase of his total annual production of apples? Answer in appropriate units of measure. You can kind of picture that the total number of bushels of apples produced is going to be his number of trees times the number of bushels per tree. That's our Algebra 1 setup. So let's define those variables. So we use an Algebra 1 setup, and now we're studying how this setup is changing. So we're going to take the derivative. The derivative of the change in total number of bushels of apples, so the derivative is R prime. Now we have to use the product rule because the trees are changing, number of trees are changing according to time, and the number of bushels per tree that each tree is producing is changing over time. So we're going to have T times B prime plus B times T prime. Now I fill in some numbers. So the rate of increase that we are looking at for total number of bushels, again, depending on how many more trees we're going to get and how many more bushels each tree is going to produce, is going to be T, so the number of trees we have is 156, times B prime. B prime is the change in bushels per tree. Our bushels per tree are going to grow by 1.5 bushels for each tree next year. So 1.5 plus B, the total number of bushels per tree right now is 12. And then the change in trees, next year we're going to expect 13 trees, so we are growing at a rate of 13 trees per year. So I'm going to put that in for T prime. So right now we've got 156 trees, and each of those trees is producing 12 bushels of apples per year. We are expecting, though, to get 13 more trees, and every single tree is going to produce 1.5 more bushels, so 13.5 bushels each, which means our total productivity, the rate of change in our total bushels of apples, is going to be 390 bushels per year. Now I know you might be asking, well, Ms. Larson, how are you getting these units? This is the formula we used, by the way, our derivative formula using the product rule. T is the number of trees, so T is simply trees. B prime is the change in bushels per tree. So if it's the change in bushels per tree, that's going to be bushels per tree but then we're going to add on that level of per year. Okay, hang on a second. Then B was just bushels per tree. T prime was then trees per year. So you may be able to see where I'm going with this. If I do some rearranging and canceling here, the product of this first term results in bushels per year. And then you can see pretty easily that the second term also results in bushels per year. So these original amounts were changing according to time. So the bushels per tree was changing according to the number of years. The total number of trees changing per year. And then our final answer was our total number of bushels was also changing every year.